follow up on that unit circle today. One thing you need to remember is if you have the coordinates of a point on the terminal side of your angle, that you can use those definitions from chapter 1 to figure out your trig function values, like sine is y over r and all of that. So if you take this point and draw the angle that would pass through it, we're going to need to figure out our value for r. So remember, r is how far it is from that point to 0, 0. So we can do a little bit of Pythagorean Theorem to calculate our distance to 0, 0. Plug in our x and y values, simplify. When you get all said and done, you're going to come up with r equals the square root of 13. And then you can go back to your definitions. We just need sine, cosine, and tangent. So sine for this angle would be y over r, which is, in our case, 2 over square root 13. So 2 square root 13 over 13. Cosine is x over r instead. So cosine would be your x coordinate over square root 13. So 3 square root 13 over 13. And then tangent would be y over x, which you already had those two coordinates to start with. So you just end up with 2 over 3. All right, so point definitions for your trig functions. Here's the unit circle, which you have all nicely filled out. If you don't have yours handy from yesterday, it's on page 119 in your book. We can use this unit circle to find some trig function values. So say you don't want to convert this angle back to degrees and draw in your reference angle and all that. You can use the fact that sine of any angle would be the y coordinate divided by r for a point on its terminal side. So if I go up to my unit circle, this condenses a lot of information in one place. If I find my point that would be on the terminal side of an angle that's 4 pi over 3 radians, point on the terminal side would have those coordinates right there. If I take my y coordinate, which is negative square root 3 over 2, and remember that the radius on this unit circle is 1, that's kind of what makes it so handy. So my r value is going to be 1, so y divided by r is just going to be negative square root 3 over 2 over 1, or just your y coordinate, negative square root 3 over 2. So it can save you a lot of work using the unit circle. Cosine, well, same angle. This time we want our cosine value, which is going to be the x coordinate divided by r. If you go back up and look at that point, your x coordinate is going to be negative 1/2. R is still 1 because we're still on the unit circle. So cosine of 4 pi over 3 is negative 1/2. Sometimes you have an angle that's not directly on the unit circle, like negative 9 pi over 4 radians. I could rotate like backwards, but figuring out where that is going to be a little bit of a pain. So I'm going to actually get a coterminal angle. When we do it in degrees, we add 360. If I do it in radians, I'm going to add 2 pi, because that's one full rotation around my circle. So common denominator. And that would get me with, if I put those together, negative pi over 4. I could add another 2 pi to make it positive, but I don't really need to. I'm just going to rotate clockwise by pi over 4 radians. So I'm doing y over x since it's tangent. So let's find that angle. Let me erase some of this. So point that would be on the terminal side of an angle of negative pi over 4 radians. Go backwards by pi over 4 would put you there at 7 pi over 4. It's equivalent angle. You can look at your x and y coordinates for the point that's on that terminal side. They're negative square root 2 over 2 and positive square root 2 over 2. If you divide those, it's really the same thing on the top and bottom of that fraction, except one's negative. So you're going to end up with negative 1. You could multiply by the reciprocal, but just realize they're the same and it's negative 1. So tangent is negative 1. So unit circle's super duper handy. You don't always have a unit circle handy or want to draw your own necessarily, so I don't want you to forget the other methods you could use to find your trig function values. So say that you don't want to make a unit circle and you don't have one. You can always multiply by pi 180 degrees over pi to convert your angle from radians to degrees. Easiest way to do it, divide out your pi's, and then 180 divided by 6 would be 30. So you get 330 degrees. Yes, you might need to do it without a calculator. So if you put that 330 degree angle in your coordinate plane, and then think about your reference angle back to the x-axis, it's back to the 30, 60, 90 special triangle. So sine would be opposite over hypotenuse. So you'd have -1 over square root 3 or negative square root 3 over 3. All right, these next couple you're supposed to approximate using your calculator. So first off, sine of 3.42 radians, you could change back to an angle in degrees by multiplying by 180 over pi and then plugging that angle into your calculator. But you can save yourself some work if you just change your calculator's mode from radians to degrees. So how you do it is you'd hit your mode button here. My batteries are low, so this probably isn't going to let me do it. Yeah, but under that menu, you could switch it from degrees to radians on one like this, which will work. You go into this DRG menu, see how it says degrees at the bottom? We actually want to use it for angles and radians. So instead, you would switch it to radians. And then you can type in sine of 3.42. Your calculator knows that's an angle in radians, and you're going to get the correct result out for your value of sine. Okay, remember there's no cosecant button on your calculator, so if you want cosecant of this angle in radians, a couple ways you could do it. You could find your sine value first, so if you type in sine of 2.7335 radians and get what your sine value is, cosecant is going to be 1 over that. So if you do 1 divided by your sine value, which leave it in your calculator, use your answer button and do 1 over it, you'll come out with a cosecant value that's approximately -2.52. You could also type it in your calculator all at once because it's 1 over sine of your original angle and get it in one step like that. And you still might want to go backwards. So we did some before where you need to find the angle that had a specific sine value or cosine value. These are going to be worded a little differently, so it might throw you off, but they're going to say find the arc length that would have this sine value. That's because by restricting these to the unit circle, your arc length and your measure of your angle are really the same thing. You can still think of it as finding the angle that has a sine value of 0.321 is totally fine. So if you want the angle that has a sine value of 0.321, that's where anytime you're looking for an angle, you'd use inverse sine. So you do have to be in radians mode. So you do arc sine of your 0.321, and you'd come up with S is approximately equal to 0.327. So you would also have to be a little bit careful, if you're going for cosecant, make sure that you change it back to a sine value. Say you wanted the arc that has a cosecant value of 2. Sometimes people still get confused going backwards here. Make sure you change it back to trig function that's in your calculator first. So you could do sine of S would be 1 over 2. And then you could do arc sine of that. If you want the exact value instead of an approximation, think about what coordinates you would be using. So we want the arc or the angle that has a tangent value of negative square root 3 over 3. So we're looking for an angle that when I divide my y coordinate by my x coordinate, I get negative square root 3 over 3. We also are told what interval we're in because there are actually 2 possible angles. We want the one that is between 3 pi over 2 and 2 pi radians. So we want the one in quadrant 4. So if you look at all of those possible angles there and all of your possible points, just try dividing your y coordinate by your x coordinate and see if it comes out to be the right tangent value. So if I use the coordinate that passes through 5 pi over 3 and divide, I could multiply by the reciprocal, I end up with negative square root 3. That's not the tangent value we were looking for. So try a different one. I'm not going to use the ones with square root 2 because ours is supposed to come out to be square root 3. So let's try the coordinates that would be on your terminal side of 11 pi over 4. So negative 1/2 for your y, 3 over square root 2 for your x. If you divide those, it's flipped upside down of what I just did. So it does come out to be negative 1 over square root 3, which simplifies to be the correct tangent value that we're looking for. So 11 pi over 6 is our angle that has that tangent value.